first thing I should do is make some noise. Maybe that's a good start. So, let's see if this is going to work. I've got a eucalypt here, the Eucalyptus tree here. This is some cuttings from the tree just outside there, and the tree is my friend. The tree gave me what I needed when I needed something. It had some rocks below it that I could sit on, had some low-hanging branches which I could reach with my cables. It was the same species of tree that I had got the DNA sequence that I'd been to the database, so everything aligned on this one tree. It was a perfect tree. So I've got some cuttings from that tree here, and I'll try and generate some audio from the tree. So what's happening here is that there were electrical impulses in living things. Doesn't matter where you stick electrodes on something that's alive, there's a little bit of pulsating electric current there. So if I start to connect, that's me, not the tree. If I connect that, we're starting to get a bit of pulse now, which is the tree. So there's an electrical current that these electrodes are picking up, and I'm putting them into a synthesizer here, and using those pulses, which are very low currents, very low signals, and I'm boosting them up to high level signals, same signals which is boosted. And this thing operates on voltage. So the signal drives the oscillators because of the voltage. Alright. So the project for the corridor project here, my project, is to interact with the land, interact with what's on the land. So this is the sound of the tree talking to me. That's why it's a monologue. I can't speak back to it. I know Dylan's got some ideas about maybe I should try and interact with the tree, and I take that on board. But currently, it's a monologue. It's speaking to me. But what I thought I'd do, I thought I'd try and play some drums to this so that I'm at least interacting with it. And I think if I put the plant in a cold, dark space, it would have a certain amount of current coming out of it. If you put it in a hot place with the sun shining in it, it'll be more active. If it's dry, if it's wet, maybe if I come to the corridor sometime, maybe I can try putting the trees in different environments, generating different audio tracks and generating different musical things out of it. Okay, so getting back to my narrative as a scientist, I work with DNA. I spend a lot of time working with DNA, and I look at DNA sequences on databases, and it's all quiet. I just go ATGC, ATGCCC, whatever. So I've got some. I run a web page with the help of my son, who's going around here, and we give it a DNA sequence, and in real time we generate audio. And I'll show you on the lovely screen behind me if I have one. DNA sequence, and I say, well, how can I generate audio in an informative way? So the first thing you can do is you can just go, well, there's 4 letters, A, T, G, C. I'm going to map it to 4 notes. So here's an example of what that might sound like. So let me just get this going. So if you listen to that, what you can hear are 4 notes. Da, 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 There's only 4 notes there, pulsing away. And each note comes from one of those bases in the DNA sequence. So think of the DNA sequence as like a train track, okay? And where the sleepers are, or where the base pairs are. So you just go A, T, C, G, A, G, 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 C as you read along it. And what happens in a cell, this is your train track, this is your DNA sequence. Proteins bind to it, and they read along like a train running down a track. So proteins bind, and then when you process the DNA metabolism, when the proteins walk along or run along the DNA, they make other DNA sequences, they make messenger RNA sequences, and they make into proteins. Okay, so DNA metabolism is all about reading along a sequence. So what we're doing here, I'm reading along a sequence, but rather than make another copy, I'm making notes. So every time there's an A, T, G, or C, you get a different note. So just reading along the sequence. Okay. The next thing you can do is rather than looking at one base pair at a time, you look at a pair of bases. So you look at 2 bases, 2 bases, 2 bases, or 2 sleepers at a time. Okay? And we're heading towards 3 sleepers at a time because that's important in biology. Biology reads 3 bases to make 1 amino acid. So it's really super important to read 3 at a time, but between 1 and 3 is 2. So I thought, well, I'll sonify 2. So when you're sonifying 2 at a time, you get this. I've generated 8 layers of audio. I've talked about 4, but there's 4 more. So there's 8 layers of audio. And so there's lots of data in the display that you listen to. So you layer in lots of data in a way that you can still listen to it without it clashing too much. But it starts to sound musical because I've started to try and apply music theory and music attributes to the audio. perspective, I find it really fascinating that normally I'm in a recording studio with musicians and they'll play something and I'll respond and play with them, and you interact with humans all the time. And then suddenly you're interacting with science data and plants and things, I start to personify the thing I'm playing to. I don't know if that makes sense. As a musician, I always find deep connections with the musicians who I play with. So when I'm starting to play with these things that are trees and sequences and stuff, my brain is fooling me to feel connections to inanimate objects. No offense to it. DNA sequences and databases and science data, you know. So I find it really interesting and quite a motivating thing to do is to interact with these musical sources. I think it's really fascinating. And it kind of speaks to this idea that Phoebe's been talking to me about bringing the life to land and voicing the land and interacting with the land. And not trying to be such a nerdy scientist, actually trying to be creative within the space where I found myself. So I guess the next thing to do is to play some drums to the DNA sequence. So I'm going to start off playing one of these telomere sequences from the Eucalypt tree sequence. So it's a fairly repetitive sequence, and then halfway through the passage we cross away from the telomere into a gene sequence and it starts to get a bit more complicated pulsing. Okay? So in my head that's what's happening. Whether you hear that, I don't know, but we'll soon find out. Let's just see if we've got a pulsing beat here. I've been going for time-wise and stuff?
No, I think we're going on 10 minutes of this.
Okay, so...
I think it's great. I mean, I don't know about everybody else. I'm enjoying myself.
Okay, I'll do one more drum thing.
Yeah.
All right.